welcome once again to the NPTEL MOOC module on handling large scale unit level data using Stata. This is our lecture in continuation to the previous lecture on binary response models. Last lecture specifically we addressed the problems of the very foundation model, very basic model called linear probability model, where the probabilistic structure of the dependent variable is attached with 1 and 0, but there are a number of limitations while we apply the OLS method. And we have already clarified that it has problem with R square, okay. It has problem with, it also exceeds the limit of the R square, okay. And then it has problem with non-normality, it is problem with standard errors, okay. So, and where the blue properties are not fulfilled. So, in that continuation we are going to test all those things with the help of data. Okay. The data we are going to consider is through our practice data. We have filtered it from our 7th round of National Sample Survey 2015-16. We are also interested in getting those factors that explain the choices of women being a necessity entrepreneur. So, as we have already given you the background during our data and introduction to national level data, where we defined what we mean by a necessity entrepreneur, okay, based on the number of workers within the entrepreneurs. And necessity entrepreneurs, whether a woman is operating within that structure or not, okay, and accordingly we are going to emphasize. So, so when we have two necessity entrepreneur or non-necessity entrepreneur or opportunity entrepreneurs, we category we coded into two in a dichotomous format, that is simply called a dummy variable. Okay. A mixture of qualitative and quantitative variables are used in the explanatory variables. The purpose here is to show how to use various data analysis commands. It does not cover the whole research process, such as verification of assumptions, models diagnostics and various follow up analysis. We just wanted to mention how we can best use the commands. Okay. Now, given our model, we have simplified through the existing variables. Now, as highlighted in the dependent variable and mentioned already, that our purpose is to understand the factors explanation behind the enterprise to be necessity type. Okay, with 1 is the 1 if it is necessity based, and 0 if it is non necessity or opportunity based. We have broadly 3 type of variables included: continuous variable, categorical variable and dummy variables. Continuous variable we have in the model, we are going to show it in Stata also. Enterprise age, square of that age, square of the age can be taken, as I already mentioned, because it might be non-linear with the variable, but not with the coefficient. Okay. So, squaring of a variable is not going to break the relationship of the model between dependent and independent. So, now dummy variables like sector, rural, urban, mixed activities, whether they have they are having or not, that is we simply coded as 0 and 1. Problem, any problem faced or not, assistance received or not, whether they are traditionally operating or non-traditional format. Okay. Similarly, categorical variable like social category we have, activity group, etc. Coming to the understanding through the data, we are going to open the data right now here before you. Okay. Now I am going to switch up to the Stata window, and in the Stata window I am going to open their data only. So, their data is here. So, it is here. Now, in the computer I have that data, and we will provide it the data to you also. Now, I am going to open this binary choice model data before you. The variable, as we just said, is going to be discussed right now. Like we have the variables like enterprise type, okay, that we discussed. So, other binary groups like sector dummy, okay. There are assistance received or not. Similarly, there are ordinal some categorical variable also, categorical variable like social category, social groups are there. Now, what we wanted to understand is the following. After opening the data, we wanted to just simply describe it. Okay, how to describe it then? Simply type DES then. Okay, if you type DES, it will actually show you. So, simply type DES. Okay, describe is going to give the nature of the data. It talks about whether your data storage is in byte form or in string form. Now, we have several times mentioned that if it is in string form, mathematical or estimation or numerical operation is not possible. You need to destring it and then you can operate it. Similarly, it also gives number of observation, okay, how many observation it has and how many variables we are dealing with. Fine. And along with that, it also gives the variable label also. Okay, the label can also be read from here. All right. Now after the describe, we are also interested to understand some minimum on background related to their summary. How this how it is there. So, simply summary of the entire variable, it gives in different format. Okay. It gives like their averages are also present, number of observation present, the minimum value, maximum value is there. From the minimum and maximum value, we can infer that these variables are dummy type. Okay. So, because 1 and 2 is there and some other categories are there 1 to 4, there are categorical type. Okay. Then from 3 to 64, 9 to 4000, these very clearly seems that they are continuous variable. Okay. So, we have clarity on this aspect as well. So, let us make a move to the next understanding. So, that is I think perfectly fine. Let us move to how we can apply LPM especially to understand the probability of women being a necessity entrepreneur based on those variables we discussed or the linear combinations of the explanatory variables. So, simply we linear model, we all know that we need to simply regress or dependent variable and the independent variables. Irrespective of dependent variable to be having only discrete choices is not the matter of concern so far as LPM is LPM technique is concerned. So, now we are going to apply. We are going to copy it and then we will go to run it. Okay. So, simply all the variables are there, we are simply going to run it with the data. Okay. So, once I enter you will get the result. Okay. Now, look at how clearly we establish the result with the help of REG command, regression command. What is interesting to note in this, it is similar to the ordinary least square result. Okay. Now, it gives R square, adjusted R square, which we used to discuss earlier. Okay. It also gives F statistics and F statistic is significant here. So, that means there is no problem with the overall model of the LPM, but there are some nitty gritty, some internal problem that we need to explore, that how it creates problems we are going to define in our other slides. Okay. Okay. So, this is what the result we have shown. Now, how we can interpret the result? This is the result we have derived just now. Now, how we are going to interpret it? Now, basically as we know that our dependent variable is not just y, it is p, it is probability, okay, of enterprise type 1, that is necessity entrepreneurs, is equal to the constant term. This is the constant term, the intercept term it is here, it is given 0.98637 constant. So, that is plus each coefficient times its explanatory variables. Okay. So, each coefficient, like first variable enterprise age. So, age its coefficient is this times its enterprise age plus plus then second variable its coefficient and the second variable third variable and its coefficient. So, if you just add everything, so that is all about the model. Okay. That is the expected value of your model. So, we can then once we add all those things and we can estimate the predicted values or the probability value of enterprise having 1, okay, or to be necessity entrepreneur. In that case, since there are so many variables and each one unit change and its impact on the dependent variable is difficult without software. Okay. So, manually we are not calculating. So, basically we are predicting its probability of success, okay, predicting the model using all those coefficient. So, in that case we will use the predictability, the predict, and we define a variable with this option that will give a linear predictions. Okay. So, now here is our prediction option. So, we will simply run this command in Stata. So, okay, just a minute. So, it is here, then it is here, then you can go to the previous slide. Okay, probably a box is selected, box can be avoided. LPM PRED, okay, we can do that, all right. PRED XP, okay. So, this is what the predicted variable we have defined, and now it is visible. The predicted variable is visible. Now, we can see and we can browse it, we can easily see how it looks like, but we can also sort these off, sort it off, and so simply sort and the variable that is the variable defined. Now, we have sorted and now we can browse. So, through the browse we can now see how it looks like, what is the probability, that is 25%, 25.44%. The first enterprise has the probability to be necessity entrepreneur, okay, of that particular enterprise could be a necessity entrepreneur. Similarly, we can have other options also, but most importantly we wanted to check some important aspects of LPM, some problems of NPM. So, we need to define whether that is within the limit or not. Okay. So, we can browse by greater than how many are actually exceeding 1. Okay. So, browse that variable, then with if that is exceeding greater than 1. All right, we need to check whether LPM has actually exceeded the probability limit of 0 and 1. Now, look at how many of them have exceeded the probability value, the predicted value. Okay. The predicted probabilities value is actually exceeded to 1. So, that is, this is very clearly violating our very assumption of the model, of the LPM model. Okay. Now, I wanted to move on and explain once again with this. We have already operated this browse, then sort, then also browse as per the interpretations, like we interpreted that 25%, 25.44% chances of being enterprise, that the first enterprise here in this list have 25.4% chances of being necessity entrepreneur. Okay. So, actually after browsing how many are exceeding that and who are exceeding the 0 value or 1 value, we have observed that actually there are many cases where the predicted value is exceeded 1, and we run this command browse, this variable we defined already. Now, this then those who are greater than 1, that has already been filtered. Okay. Now, we can conclude that LPM is not actually fulfilling the condition of the limit of the expected values, okay, the predicted values. We can look at a plot also to understand their residual values against probabilities of all the observation in our data set. So, RBA plot is going to give us that result. RBA plot, the residual edge is going to be defined. Okay. Now, it has come. Now, look at the same thing can be also interpreted here. Now, on the left hand in the vertical axis is residual, these are the fitted values. Now, the fitted values there are 2 points you can easily see even on the first line and even near where the another one there are some outlier very clearly identified is exceeding one value. 1 is here, now it is exceeding that one value. Okay. So, this is what I wanted to discuss. So, RBA plot actually discusses the residuals, and this is how it looks like. So, we see here that for each y hat the residuals are free to take on only 2 values. It can be concluded that the residuals are not normally distributed. Okay. So, residuals are actually not at all normally distributed, and that too there are some outliers as well. So, notice we notice that from the plot that RBA plot that there are values of y hat that fall even outside the range, that is 0 and 1. Okay. So, this is because LPM places no constraint on the range of y hat, letting them range between negative infinity and infinity. So, we have probabilities greater than 1, this would indicate that there is a problem with the credibility of our model. Okay. Now, coming to the another sophisticated model called Logit. Now, based on the earlier understanding that LPM is the simplest format where we simply apply the linear probabilistic structure, but it attaches with number of shortcomings, residuals as well as its predicted values are actually explaining that that is not a good model. Now, we are discussing another binary choice model, binary response model called Logit. Logit model is applied where the distribution actually follows a logistics distribution or logistic structure. Okay. So, we are going to discuss that in a short while. LPM in fact assumes that the probabilities value increases linearly with x. That means, the marginal or incremental effect of x remains constant throughout, but actually we have seen that it okay, the marginal impact should remain constant throughout, but there are some problems in the model. But in reality one would expect that pi is non-linearly related to xi. Okay. So, so it is not linear with xi. As we need a probability model that characterize the xi's increases pi pi that is with success as 1, but never fall beyond a range of 0 and 1. The relationship between pi and xi is nonlinear. Okay, that is also required. Now onwards we will be emphasizing this aspect. Models with such characteristics are Logit and Probit models. Okay. Both theoretical and empirical considerations suggest that when the dependent variable is a binary variable, the shape of the response function will frequently curvilinear. Okay. So, the Logit and Probit function follows the sigmoid curve or the S-shaped curve. The sigmoid curve, if any, follows okay, the showing a nonlinear relationship between pi and xi. Okay. That is the probability of the y with that of the explanatory variable should be nonlinear. That means one approaches 0 at 0 at slower and approaches 1 at slower and slower okay, gets small and approaches 1 at slower and slower rate at xi gets very large. Okay. So, basically when I mean in the every extreme points the value, the pi's values is actually approaching to a slower rate so far as sigmoid curve is concerned. The Logit model actually follows a cumulative logistic distribution function. So, this looks like this. So, with the higher values it approaches to approaches to a slower rate, even at the lower value also approaches to a slower rate. So, that is all about the cumulative distribution function of a sigmoid curve, okay, or the Logit curve. So, logistic regression actually follows number of assumptions, important assumptions. Without that, logistic regression is not wise to define. So, now what are the important assumptions? That logistic regression does not require a linear relationship between the dependent and independent variable. That is one of the most important aspect. So far in the earlier models, we only discussed linear relationship. So, Logit and even Probit not necessarily require linear relationship, okay. That can be converted to a linear format for estimation, but originally they do not require linear relationship. The dependent variable in logistic regression is not measured on an interval or ratio scale, that is on binary or in categorical format. The residuals actually do not need to be normally distributed. We already defined that residuals should not be forcefully kept or forcefully defined to be normally distributed, because they have only binary choices, okay, at this moment, not necessary even as per the assumption of the Logit. Homoscedasticity is also not required, okay. So far we said there are problems of homoscedasticity. Even if it is not there, still we can define that Logit model is going to be one of the fittest model, okay. Logistic regression requires the observation to be independent of each other, okay, and it should come from repeated measurements or matched data. This requires little or no multicollinearity among the independent variables. So, independent variables should not be also correlated as per the assumption we normally take in all the models so far. This assumes that independent variables are linearly related to the log of odds, okay. So, once we define the odds ratio, then log of those odds are actually related to the linear related to the independent variable. We are going to clarify this with the help of equation, okay, log of odds. The logistic regression typically requires a large sample size. Sample size, if it is they are better, then this is one of the better models. Coming to the application through the theory, coming to the clarification of the logistic regression model through the mathematical theory is as follows. Like this Logit model is also called a logistic regression model. Okay, Logit model is based on the following cumulative distribution function, which we have already defined. That from that basically probability of success, that is 1, should follow a cumulative function or a sigmoid function, which is generally expressed with help of exponential diagram e to the power z. E to the power z is the distribution. Z here is the expected value of the model. 1 upon 1 plus e to the power minus z. Okay. So, z here is our standard expected value. Now, so this equation is written can be written like this. Since we said minus e to 1 plus e to the power minus z e to the power minus z I. So, if this will be 1 plus, this will be certainly is equal to, okay. So, this will be is equal to then 1 upon 1 plus 1 upon e to the power z, then this will be is equal to e to the power z 1 plus e to the power z, then e to the power z divided by 1 plus e to the power z. Okay. Alright, so this is what e to the power z I, then 1 plus e to the power g I, which is nothing but called the distribution function of the logistic model. So, this represents this f function or the cumulative logistic function. The probability at any point can be defined through this particular equation so far as the logistic distribution is concerned. It is visible from the function that a z I ranges from minus infinity to infinity, okay. P I ranges from 0 to 1, alright. So, from the diagram, if you could just look at once again, so z I varies from minus infinity to infinity, but the probability limit varies from 0 to 1. Okay. So, the probability we are going to define here, the z values or the x values we define, z values composed of x values is defined here. All right. So, I will okay, just a minute, I will come back. Okay, estimation will come back. All right. Okay. So, let me explain another slide, then we will get it forwarded to the next class. Now, coming to the discussion of the ranges of the z function, z z or the expected value of the probabilistic function as pi, that is 0 and 1. So, now another important aspect is that pi is non-linearly related to z I. Okay. So, pi is here, pi is non-linearly related to z I. Okay. Even in the diagram also it is non-linear. Okay. So, pi is non-linear not only in x, but also in betas. Okay. The betas, the beta values, because beta values are where beta values are actually defined here. So, the pi is not just non-linear to xi, this is also non-linear to, because it is e to the power something. So, it is also non-linear to its beta values as well. All right. So, this means that OLS can never be used when it is completely non-linear. So, this equation can be linearized to apply the OLS technique. Okay, can be linearized for further interpretation. So, accordingly we can define an odd ratio. Okay. So, this is the last slide of this lecture, then we will carry forward. So, that the probability of success and is pi, and 1 minus pi is the probability of failure, where probability of success we said it is e to the power z divided by 1 plus e. So, it will be or 1 upon 1 plus e to the power z I, then 1 minus this one, it will be equal to this. Then the success divided by failure, success divided by failure, this is nothing but called odd ratio, is pi upon 1 minus pi, which is equal to, if you divide the success divided by the failure, and this is what we already defined, the success and failure, it boils down to be e to the power z I. Okay, g I. So, pi and upon 1 upon pi is simply called odd ratio. This is what we said, odd ratio. The log of odd ratio, if I take a log of it, natural log of it, this is basically z I. Okay, z I. Log of this, log of pi upon 1 minus pi, 1 minus pi is nothing but only z I, isn't it? So, z I is basically beta naught plus beta naught plus beta 1 xi, beta I xi. Okay, beta I xi. All right. So, now look at, this is linear related to the log of the odd ratio, okay, which is the point I think we wanted to clarify somewhere in the linear related to the log of odds. Okay. So, this is what we just clarified. And odd ratio in favor of success, and that is basically the success to the failure ratio, and we have clarified. So, if we take the natural log of that odd ratio, that is nothing but beta naught plus beta 1. If you have only one coefficient to be defined, then this is only beta 1 xi. Okay. Then the Li stands for the log of, Li is the notation for log of odd ratio, is also called Logit. Okay. This is called Logit, and that can be estimated. Hence, the above model is named as Logit model. Li is not only linear in x, but also linear in terms of parameters. Okay. So, because parameters it is linear, this is also linear with x. Okay. So, now rest of the details features of the Logit model and its application with Stata and why it gives way forward for Probit model, we will continue from the next class. With this, let me stop here. Okay. Thank you so much.